Hi gang, this is Eric White. This is screencast number 22 in this series on recursive pure functional transformations. And in this screencast, we're going to talk about tuples. Now, I have to tell you, I use a kind of a funny little vernacular. I sometimes, in explaining this, I say that this is tupleizing and detupleizing. I don't think that this is actually real proper terminology for working with tuples, but it kind of explains what I'm trying to do with tuples. I use tuples all the time in the various modules in Power Tools for OpenXML. As an example, I use them in Document Builder. I've used them in Revision Acceptor. I've certainly used them in the HTML converter, so on and so forth. This idea of creating tuples to carry values through a query so that you can use them later on is an important idea. So let's take a look at a super simple example. Wikipedia lists a number of definitions for tuples. The particular one that we're talking about is this one here in computer science, where tuples are directly implemented as product types in most functional programming languages. This statement here, more commonly, they are implemented as record types where the components are labeled instead of being identified by position alone. That's relevant. Another way to think about tuples in the context that we're talking about them is that they are name-value pairs. We'll have a collection of name-value pairs. Let's say that our job in this particular programming task is to break up this collection here into collections of either 3 or 4 or some particular number. In order to break up this collection, the easiest way to do it is to project a tuple, in other words, a set of name-value pairs. There will be 2 name-value pairs in this tuple, where one of the values is the actual value that we're projecting, and the other is the set that it's going to go into. Let me show you what I mean by that. So I'm going to take our list, and I'm going to project. It's an integer, so I'll use I. And now I'm just going to move right into an anonymous type. Anonymous types are one of the common ways to make a tuple. It's not the only way. You can certainly use named types, and I'll show you an example of that after I show you with the anonymous type. In this tuple, the first thing is I have a value. I'm going to call this V instead of I, and the reason I want to do that is select has an overload where it takes 2 arguments into the lambda expression. The first is this V, which is each item in the source collection, and the second is I, which is an index. The first one coming in will have an index of 0, the second one coming in will have an index of 1, and so on. So let's say I want to chunk this collection up into chunks of 3, then I can take I over 3 and I can make that be my chunk values. This item is item 0, so the chunk will be 0. This is item 1, the chunk will still be 0. This is item 2, and the chunk will still be 0. And then finally we get to this item 3, and the chunk becomes 1. Close off the select. And now I'm going to iterate through all of these values and show you what we have. And we can see what we expected to see. We see 03, 01, 04, 11, 15, 19, 22, 26, 25, and so on. So it's coming up with the right chunk number. So now the next thing that we can do is we can group them by that chunk. So I'll just dot into. And I often use the lambda expression variable of a name of t when I have a tuple. That's just something that I do often, not always. So I'm grouping by the chunk value. So instead of this being item, I'm going to call it chunk collection. First thing I'm going to do is I'm going to print out the key of this chunk collection. This will be our 0, 1, and 2. And now I'm going to iterate through every item in that chunk collection and print those out. So I actually have to dot into that value property because this value in chunk collection, that's going to be one of these anonymous types, this tuple up there. And finally, I'm going to print a line in between each one. And I'll print a underscore line up here so that we can get a nice printout, see where our collections of chunks are. So we can see up here, chunk 0 has 314 in it. Chunk 1 has 159 in it. Chunk 2 has 256 in it, and so on. Let's say that we didn't even care about which chunk number it is. We only want things to be chunked. We don't care whether it's chunk number 0, chunk number 1, and chunk number 2. Well, we're carrying around that key in that chunk. Well, we can detuplize it so that we don't keep around chunk number 0, chunk number 1, and chunk number 2. Instead, we just want the values all grouped together. So after grouping by t.chunk, I am now going to select, and this is a group now because things are grouped, and this group is a collection. So I'm going to take G, and again, I'm going to dot into select because I only want to get the value of that tuple. So the group child dot value. I have to put this at the beginning of a lambda. So in this particular case now, what I've done is I've taken each one of these collection of chunks, and here I've dotted in and projected the value only, so I've effectively detuplized that collection. So at this point in time, I no longer have a collection of groups. Instead, I just have a collection of collections at the end of this select statement. So I'll get rid of this key, and now I can iterate, first of all, through my collection of collections, which is in group. Now I've got the chunk collection, and for each value in chunk collection, I don't have to dot into value because this is now no longer a tuple. It is just the integer value. So when I run it, I see all of my integers grouped together. So instead of having a collection of groups where each group has a key and a value, at the end of this query right here, I now just have a collection of collections. So in this query, I have first done my, quote, tuplizing, unquote, where I create an anonymous type that has two different name-value pairs. There's the value name-value pair and the chunk name-value pair. I do whatever intermediate operations I need to do on that collection of name-value pairs. In this particular case, I want to group by one of them. And after grouping by that one, I no longer need it. So I go into this particular selection statement here where I detuplize it. I get rid of the tuple and go back just to the values that I'm interested in. This is a very simple example, but there are certainly complicated cases where I'm writing a query that it might be a string of queries that each query is 20 lines long in the query. And in the middle query, I have to calculate a bunch of intermediate stuff to get the results that I want. And I don't want to carry that intermediate stuff around afterwards. So part of the cleaning up process is to, quote, detuplize, unquote. So in a real world, we might have a situation where I might want to select just a region of this document and create a new document that contains just a portion of this document. Let's say that I want to find some particular element in this document, and I want to select the 2 paragraphs previous to that element, and I want to select the 2 paragraphs following that element, but in the end I want to put together a new document that just contains those relevant paragraphs. So how can I do this? Well, first thing that I'm going to do, I need a new document, so I'll new up a new document. And I need a body element in that document also, so now let's go up here and let's say that we have calculated previously that I want to get 2 paragraphs before paragraph number 5 and 2 paragraphs after paragraph number 5. So if this is paragraph 0, paragraph 1, 2, 3, 4, 5, we want 2 paragraphs before this paragraph that says you can also format text directly. So somehow or other, in some previous query, I've calculated that number 5. That's the center of the selected content that I want to create for my new document. So now I'm ready to write my query where I'm going to project into a tuple, do the interesting things I need to do with that tuple, and then detupleize, get rid of that so that I can fabricate my new document appropriately. So at this point in time, this statement right here, I have a collection of all of the paragraphs in this document. So now I'm going to project into a new tuple where I'm going to keep around the paragraph number. So again, I'm going to use a lambda expression with 2 arguments. The first argument is my p for paragraph, and the second argument is I for index. And I'm going to new up a tuple, so it's going to be an anonymous type, and I'll say paragraph is equal to p, and that paragraph is going to be an X element because that's what we're projecting over. And I often use this particular nomenclature where I'm projecting into a tuple where I need to keep this index around. I use index for the name of that member in that tuple. You'll notice something. I often, almost always, put this final comma on the ending initialization of a name value pair in a tuple. It certainly just makes editing further on easy. I never know when I'm going to come back in and add another member to that tuple. So I always just put a final comma on that. It's valid in C# to do that, so I take advantage of that to make my editing job easier. So there we have projected into a tuple that has a name value pair where the name is paragraph and the value is an X element, and the name is index, and the value is this index of that particular paragraph in the document. And now I can .where. Because I have a collection of tuples, I'll use my t value. And then I'll say t.index is greater than or equal to selected paragraph minus 2, and t.index is less than or equal to selected paragraph plus 2. And that's going to return a collection of tuples of just the paragraphs that we're interested in. And now I want to detupleize. I want to get rid of that tuple so that I am just projecting a collection of paragraphs or a collection of X element objects. So again, I need to .into select, and again, I still have a tuple at this point in time, so I use t. and I'm going to return t.paragraph. I'll close off that selection. This closes off the constructor for the body element. That closes off the constructor for the document element, and we are done. And I can print out this document. So when I print this out, what we should see is we should see a new document that has 5 paragraphs centered around this paragraph. You can also format text directly. So let's see what we get. And we can see, in fact, the center paragraph is you can also format text directly, and we see the 2 paragraphs before it and the 2 paragraphs after it. This is another example of tupleizing and detupleizing. Now, I've used an anonymous type in both examples that we've seen so far. That's not the only way to do it. It's also certainly possible, and in many cases desirable, and in some cases required that you use a named type. I will make a class. I'll call it para_index. This is a class that is only used for a very short amount of time, so I don't have to be too awfully particular about what I name about it. I can even make this class, I can declare it inside of my other class. That's something that I commonly would do also. And I have to put in public xElement paragraph. I can declare this as a field just like this. This is a perfectly valid way to code. You don't have to make them properties. You can make them fields, and it can result in very slightly more optimum code. And there's no good reason to make them properties. If we needed to make them properties, we could make them properties at some point in time. I also need a public int index. And now I can change this down here, and all I have to do is put in new para index, call the constructor, and the value initializers use the exact same syntax as when you're newing up an anonymous type. So that's all I have to do this. If I run it, I get exactly the same results. And now I'm using a named type or a nominal type instead of an anonymous type. There's a funny case where you have to use this. When you're writing C# code that is compiled interactively in PowerShell to create a commandlet, something that's interesting is that it won't allow you to use anonymous types. So you have to change them to be named types in that scenario. There are other cases where you want to declare this class because it helps to document your code. That in order to see what you're projecting at some particular point in time, another developer reading your code can come up here and look at para_index and say, this is a tuple class, and it has 2 members in this tuple class. One's paragraph, and it's a type of xElement, and the other's index, and it's a type of int. In other words, it's a way to make your code more self-documenting. We can go back to our other program here, and I can put in a private value chunk, and in here I'll put a public int value and public int chunk. I'll put my semicolon on that to make the compiler happy, and I can now instantiate a new val chew, and all of the remaining syntax is the same. Another case where you can't use an anonymous type is sometimes you will be doing one of these projections into a collection of tuples, and you need to return this collection from a method. And it's better to return a collection of named tuples rather than anonymous types. Anonymous types should be scoped to within a method and only to within a method. You can do tricks with a language to use anonymous types outside of a method. I think it's a really bad idea. If you are returning a collection of tuples from a function or from a method, it's better to use a named type. So if I run this fellow, it runs exactly as it did before. That's all I'm going to cover in this video on tuples. In this video on tuples and in the last video on grouping, these are important tools to have in your toolbox for doing recursive pure functional transformations. Thanks for watching.